The James Webb Space Telescope is so powerful, it can spot light that's been traveling for over 13 billion years. As the universe expanded, this old light stretched, too. When we look at the farthest galaxies, we're basically peeking back in time to almost the Big Bang. Even though the universe seems huge, everything started from a tiny point, called a singularity. This is how we understand the Big Bang right now. But the James Webb Space Telescope, JWST, has shown us some crazy things about how the universe started and changed, leaving scientists amazed. Brian Cox, a famous physicist, even said that the JWST's awesome new findings might totally change how we see the universe as a whole. So, let's check out some of these space discoveries that could change what we know. The JWST, named after James E. Webb, who used to run NASA, is a super cool piece of tech that's way better than the Hubble Space Telescope. NASA, the European Space Agency, and the Canadian Space Agency teamed up to create it. It's got some awesome new stuff and is designed to capture the universe in amazing detail. Unlike Hubble, the JWST takes super clear, high-res pictures of stuff far away in space, mostly using infrared light. This lets it see through space dust and show us things we couldn't see before. Its massive primary mirror, which is 6.5 meters wide and made of 18 hexagon pieces, is way bigger than Hubble's mirror. It hangs out about 1.5 million kilometers from Earth at the second Lagrange point, L2, circling the Sun with us, giving it a steady view of the universe. Looking far into space isn't just about how far away things are, but about looking back in time. The JWST's infrared tools let scientists check out space stuff and happenings from billions of years ago. As the universe gets bigger, light from these old objects stretches out, shifting from visible light to infrared. Luckily, the JWST can detect this light, so researchers can study how stars form, how galaxies change, and check out the air around planets outside our solar system. One of its coolest recent finds is a huge group of galaxies way out at the edge of the observable universe. This makes us rethink what we thought we knew about how the universe formed early on and makes scientists rethink the basics of cosmology. To get how big of a deal this is, let's look back at the history of astronomy. Ancient folks like the Greeks and Chinese started by watching the planets move. In the 17th century, Newton's laws gave us a way to understand gravity and how things move in space. Then, in the early 20th century, Edwin Hubble made some groundbreaking finds. He saw that distant nebulas were actually galaxies outside our Milky Way, which changed how we saw the size and movement of the universe. Hubble's law showed that galaxies farther away from us are moving away faster, proving that the universe is expanding. After World War II, the space race kicked off with Sputnik in 1957, followed by Yuri Gagarin's orbit in 1961 and the Apollo 11 moon landing in 1969. These were huge moments in space stuff. The Hubble Space Telescope, HST, launched in 1990, starting a time of awesome pictures and space insights. Going from ancient skywatching to the JWST shows how much we want to learn about space. The HST took famous pictures like the Pillars of Creation in the Eagle Nebula, showing us where stars are born in huge clouds of dust and gas. It also revealed thousands of galaxies in what looked like empty space in the Hubble Deep Field. Plus, the HST checked out the air around exoplanets, finding water and organic stuff, hinting at life beyond Earth. By studying a supernova, SN 1987A, Hubble helped us figure out how big stars live and die. All this made Hubble a legend in astronomy. Its replacement, the JWST, was built to go even further, especially to explore the beginning of the universe, thought to be around 13.8 billion years ago. The main idea is that the universe started from a super hot, dense point that quickly expanded. As it got bigger, matter, energy, and forces appeared. Cooling eventually made atoms, stars, galaxies, and the structures we see today. The Big Bang model also covers cosmic microwave background radiation, what the universe is made of, and how it's structured. Even though it's widely accepted, the theory faced some doubts early on. Other ideas, like the steady-state theory, suggested the universe was always there without a beginning. People weren't sure about the singularity, expansion, and some weird things they saw. But over time, most of these questions were answered, especially after finding CMB radiation in 1965, which really backed up the Big Bang theory. Later missions like COBE and WMAP gave us even better measurements, confirming the theory with crazy accuracy. That's where the JWST comes in, with its awesome infrared detectors that can see through space dust and spot the earliest light out there. This lets it zoom in on where stars are born, watch star nurseries, and find stars that Hubble couldn't see. Since infrared light has longer wavelengths, it can pass through dust, revealing hidden parts of the universe. The JWST is also great at looking at cooler stuff in space, like brown dwarfs, far-off galaxies, and exoplanets that might have life. As galaxies move away, their light stretches out, redshifted. The JWST's infrared sensors detect these signals, giving us a peek into the earliest days of the universe. Crazy events like black hole crashes and star births often send out energy in infrared. So, the JWST doesn't just add to what optical telescopes do, it goes way beyond, showing us stuff we couldn't see before. Recently, it found something totally mind-blowing, huge galaxy structures from only a few 100 million years after the Big Bang. These early galaxies look bigger and more developed than we thought they'd be. This means that galaxies might have formed faster and more chaotically in the early universe than we expected. These finds are a big deal. They challenge what we thought we knew and hint at unknown things going on in the early universe. The JWST's observations are making cosmologists rethink their models, especially about how structures formed and how galaxies changed. The number and maturity of these early galaxies are also surprising. Many have complex features that don't fit with the idea of slow, steady growth. Instead, we might be seeing fast, large-scale changes that suggest a denser and more complex universe than we thought. Differences between what we see and what we thought we'd see have sparked debates among scientists. How could such big things form so quickly without breaking the laws of physics? Could there be unknown things happening? The answer might be in more observations and deeper analysis. One of the coolest things it found recently was a giant group of galaxies way out at the edge of the universe. This throws a wrench in what we thought we knew about how things came together in the early days and makes scientists rethink some basic ideas about the universe. To see how we got here, it helps to look back at the history of astronomy. Ancient people, like the Greeks and Chinese, got things started by watching the planets move. Then, in the 1600s, Newton came up with laws that explained how gravity works and how things move in space. In the early 1900s, Edwin Hubble made a huge discovery. Those fuzzy things called nebulas were actually galaxies way beyond our own Milky Way. That changed everything about how we saw the size and movement of the universe. Hubble also figured out that the farther away a galaxy is, the faster it's moving away from us, which was big proof that the universe is getting bigger. After World War II, the space race took off with Sputnik in 1957, then Yuri Gagarin orbiting the Earth in 1961, and the Apollo 11 moon landing in 1969. It was a wild time for space. The Hubble Space Telescope launched in 1990 and showed us amazing pictures and info about space we'd never seen before. Going from just looking at the sky to using something like the JWST shows how much we want to know about the universe. Hubble took some famous pictures, like the Pillars of Creation in the Eagle Nebula, where you can see stars being born inside giant clouds of dust and gas. It also took the Hubble Deep Field picture, which showed thousands of galaxies in what looked like an empty spot in space. Plus, Hubble checked out the air around planets outside our solar system and found stuff like water and organic stuff, which could mean there's life out there. By studying a supernova called SN 1987A, Hubble helped figure out how big stars live and die. All this made Hubble a legend in astronomy. The JWST came along to take things even further, especially when it comes to checking out how the universe started, which we think was around 13.8 billion years ago. The main idea is that the universe started from a super hot, tiny point that blew up really fast. As it got bigger, matter, energy, and the basic forces of nature showed up. Things cooled down, and then atoms, stars, galaxies, and all the big stuff we see today came to be. The Big Bang also explains the cosmic microwave background radiation, how much of each element there is, and the big structure of the universe. Even though everyone pretty much accepts it, the Big Bang theory wasn't always popular. Some people thought the universe was just always there and never started. There were also questions about the singularity, the expansion, and some weird things that didn't quite fit. But over time, most of those questions got answered, especially after they found the cosmic microwave background radiation in 1965, which was a big win for the Big Bang. Later missions gave us even better measurements and proved the theory was super accurate. That's where the JWST comes in. It's got these fancy infrared detectors that can see through space dust and pick up the earliest light ever. That means it can focus on places where stars are forming, watch stars being born, and see stars that Hubble could never see. Because infrared light has longer waves, it can go through dust and show us hidden parts of the universe. The JWST is also great at looking at cooler stuff in space, like brown dwarfs, faraway galaxies, and planets that might be able to support life. As galaxies move away from us, their light stretches out and turns redder. The JWST's infrared sensors can pick up these signals, giving us a peek into the early days of the universe. Big events like black holes crashing into each other or stars being born also send out energy in infrared. So, the JWST doesn't just help telescopes that see regular light, it goes way beyond and shows us things we could never see before. Recently, it saw something truly mind-blowing, huge galaxies that were around just a few 100 million years after the Big Bang. These galaxies look bigger and more developed than we thought they would be. This means that galaxies might have formed faster and more chaotically than we expected. These finds are really important because they challenge our theories and suggest there might be unknown forces or conditions at play in the early universe. The JWST's observations are making scientists rethink their models, especially when it comes to how things formed and how galaxies changed. The number and maturity of these early galaxies are also surprising. Many of them have complicated features that don't fit with the idea that they grew slowly and steadily. Instead, it looks like things happened fast and on a large scale, which suggests the universe was more crowded and complex than we thought. These differences between what we're seeing and what we thought we knew have started some lively debates in the science world. How could such big things form so quickly without breaking the laws of physics? Could there be unknown things happening? The answer might come from more observations and deeper analysis. In astronomy, the first sightings often lead to surprises. When we look closer, we often find more complexity in how galaxies are built, what they're made of, and how stars act than we originally thought. Spectroscopy, which is using light to figure out what things in space are made of, is a big deal. It helps us figure out what's there, how hot it is, how dense it is, and how it's moving, which gives us a better idea of how stars and galaxies change. The JWST has already shown us that our first ideas can be wrong. Studies pointed to simple galaxies made mostly of hydrogen and helium. Now, spectroscopic data is showing heavier elements and weird stuff in the early universe, which is changing what we thought about space chemistry. We're seeing the same thing with how galaxies grow. We used to think it was pretty much the same everywhere, but the new data shows way more variety and complexity. This means the early universe was way more diverse than we imagined. Finally, one of the coolest things the JWST can do is study the air around planets outside our solar system in detail. By looking at the light that shines through these atmospheres, the telescope can spot important chemicals like water, methane, carbon dioxide, and organic molecules, which could all mean there's life there. The JWST is also changing how we understand stars being born. It can see through gas and dust to watch stars come into existence, giving us a better idea of how systems like our own solar system formed. This helps us piece together the story from cosmic dust to planets where can live.